Let's take a look at how we measure the distance between notes. We classify the distances into something we call intervals. The system of intervals is very much a system of quantification where we simply assign values to the distance between notes, which has no intrinsic meaning of its own. Understanding intervals, however, is foundational to understanding any other aspect in music and harmony, so we will cover this very crucial system carefully. The first aspect of intervals is interval type, of which there are 8, and that's the distance between notes as counted on the staff. For example, E and E are the same note, and we call that a prime. E and F are a note apart, and we call that a second. E and G a third, E and A a fourth, and so on, all the way up to E and E, 8 notes apart, which we call an octave. Anything past that is simply reduced and called a compound interval. For example, this would be a compound second. For this reason, we'll only deal with these distances. Each of these interval types also has a quality, perfect, major, or minor. The only 4 intervals that can be perfect are primes, fourths, fifths, and octaves. All other intervals can be major or minor. Now you may have heard the terms major and minor to describe harmonies, sometimes meaning happy or sad harmonies. In this case, we are simply dealing with a mathematical distance, which has no meaning of its own. It's important to note that major and minor in intervals simply means bigger and smaller. For example, a second can be minor, smaller, or major, bigger. If we keep with the direction of our chart, larger being this way and smaller that way, we'll arrange our minor and major intervals in this manner. While interval type is measured on the staff, interval quality is measured in half steps, and the keyboard is the easiest place to do this. Keep in mind the half step is the smallest distance between 2 notes, or any 2 neighboring notes such as B and C, G and G sharp, D and D flat. Notes such as A and B are not a half step apart. If we use the example of E and E as a prime, we see that a prime is 0 half steps apart. Following this pattern, a minor second, such as E and F, is 1 half step apart. A major second is 2 half steps, and so on all the way to 5 half steps for a perfect fourth. If we measure the distance in an octave, we find that there are 12 half steps. Counting backwards, we arrive at 7 half steps for a perfect fifth. And now we see that we're missing something. 6 half steps is known as a tritone and can only be achieved one of 2 ways. There are 2 interval types we have not yet discussed: augmented and diminished. Augmented is essentially 1 half step larger than the maximum distance of an interval. For example, a third that is 5 half steps, such as C and E sharp. Diminished is an interval that is 1 half step smaller than the minimum distance of an interval. For example, a seventh that is 9 half steps, such as B and G flat. Therefore, we could construct the tritone using an augmented fourth or a diminished fifth. The last aspect to interval is their consonance or dissonance. There are 3 dissonant intervals: the second, the seventh, and the tritone. You'll notice these are inherently unpleasant sounding. They're dissonant because the frequencies of these notes does not overlap evenly. The remaining intervals are all consonant because their frequencies overlap more evenly. More on that in another video. When measuring intervals, remember to maintain the proper order of thought. First measure the interval type on the staff, then the interval quality by half steps. Mixing up the order can sometimes give you the wrong measurements. Also keep in mind that interval types are measured starting from 1 prime on the starting note, while quality is measured from 0 half steps on the keyboard. So far we have learned to measure the distances between notes, but everything we have covered so far deals simply with quantities which have no inherent meaning. In the next video we will introduce harmony, or in essence, musical meaning.